Bismillahirrahmanirrahim. Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera sekali lagi. Okay, this is the second part of chapter 2, properties of pure substances. So I will share with you the second slide. That's okay. Second part of slide. Based on the title of this slide is properties table. So seperti biasa I would like to acknowledge this slide lecture notes is from UiTM Shah Alam, and this slide is produced by my members colleague Dr. Idris Saad, and reviewed by Dr. Hassan and also Dr. Afifah. Thank you very much to them that has produced this slide. So I just continue with this slide because the slide is same as this Thermodynamics MEC 450 as same as our course MEM 462. So the second part of the properties of pure substances is based on the properties table. Okay, let's go and let's see what is the properties table mean. Okay, most substances, that means the relationships among thermodynamic properties are too complex to be expressed by a simple equations. So that means there are a lot of properties out there, okay, in the world that can have a relationship among thermodynamics. So so to make it more not complexible, or to make it more easily to handle, the properties are frequently presented in the form of table. Okay, that means kita tak tengok yang banyak-banyak tu dalam bentuk eksperimen. So now these properties has been experimented by researcher or expertise, and then they form in term of form of the tables. So some thermodynamic properties can be easily measured, but other cannot and are calculated by using the relations between them and measurable properties. So the result of these measurements and calculations are presented in the table in a convenient format. So as you see at the left of this slide, okay, this one, this is a properties table booklet, and this properties table booklet come from the author Chengil, okay, Chengil author. So actually you can download this properties table booklet from UFuture in my course MEM 462. So dalam tu ada saya letakkan this properties table booklet. So kamu boleh download from there. Also the notes, lectures ada juga dekat situ. So actually if you look at this properties table booklet, this is a example, okay, examples of the booklet. So ada banyak table, there are many tables in that booklet. Ni adalah table A4. So macam ni lah bentuk dia. And at these tables, you can see example for table A4, it is saturated water. Okay, saturated water, and it also showed temperature table. So in this saturated water, it have the properties of temperature, also saturated pressure, okay, and also it has a properties of specific volume, that means V, small v, internal energy, this is specific internal energy because the unit is kilojoule per kg, so this is small u, this one u, ini V, specific volume V, and it also show UF UFG, UG. That's mean this what it mean. It is mean what I have present or I have show you the slide in part one, where you have to know the curve line in PV diagram and also TV diagram. There were a line that called the saturated liquid line and also saturated vapor line. So this is internal energy, specific internal energy. So this also it show the properties of enthalpy, the unit or the exactly name is specific enthalpy because the unit is per kg, and also specific entropy. Okay, and it's symbol by S. Okay, S. Dia juga tunjuk kat sini FF, SFG, SG. H, as same as I said, H also ada HF, HFG, and HG. So from there, it also have table A4, table saturated water. Same as I mentioned, properties yang ada tu disenaraikan, listed there. And also another table is table A6, that is for superheated water. What it mean by saturated water, superheated water? Okay, when you deal or when your case of calculation analysis is based on the mixture region, that's mean mixture region, that's mean the phase the substance phases in mixture region are liquid and vapor. Okay, that mean in dia di bawah bukit ataupun line yang saya terangkan sebelum ni. So that is a region of mixture. So when you deal or you want to make a calculation analysis based on the region, you have to use table A4 and table A5. That means for saturated water and also for saturated water pressure table. If you want to analysis and make the calculation based on the right side of the graph, that means on PV diagram at the right side, so it is superheated region. So when it is superheated region, you have to use table A4, superheated region ataupun superheated water. Okay, okay. This is a example of the tables that in properties table. Let me show you uh, the properties tables that have in U future. Okay. Okay. Loading quite slow. Sementara kita tunggu tu, ada apa-apa tanya pasal tadi yang baru masuk satu slide properties table. Tak ada Allahu Akbar, awak slow sangat ni. Okay. Okay, this is the properties table booklet by Chengal. Okay, this is properties unit. Kemudian dia ada it show all the general information tables. Okay, this is the table for properties mass. From here you know the substance, air, ammonia, argon. Okay, from here, and then also it show the formula of air, of ammonia, molar mass, gas constant, etc. Okay. So this is the ideal gas. Table A2 is the ideal gas specific heat of various common gases. That means at a temperature 300 Kelvin. So this all the result from the experiment that they expert obtain. So they put in here, and the CP, CV for all the substances, CP and CV, and also a gas constant R. Okay, that will be covered in part 3. Okay, sekarang ni saya sebut saja, so you just listen, and in part 3 chapter 2 you will learn or you will know about the gas constant, CP and CV, and also K. Okay, this is a properties tables A2. Okay, also A2. We jump to A4. Okay, A4, as I mentioned, A4 for the saturated water. That means for mixture region. Also A4, A5, table A5 for richer region. Table A6 for superheated. That means for vapor region ataupun dalam keadaan gas, the phase of the substance is in the gas phase. Okay, gas phases. That means dalam keadaan fasa gas. Baru kamu pakai superheated water kat sini. So it show temperature, specific volume, specific internal energy, specific enthalpy, specific entropy, and also P is stand for pressure. Okay, pressure in between 0.01 megapascal, 0.05, 0.1, and blah blah blah. Okay, that is for superheated. So okay, we continue with the slide. Okay, saturated liquid and saturated vapor states. Okay, as you see, part 1 slide, in T or P versus specific volume, there are two lines that show the saturated liquid line and also saturated vapor line. Okay, these two lines. So this line actually memisahkan. Okay, it separate the compressed liquid region and also mixture region. And this saturated vapor line separate the phase of mixture regions and superheated vapor region. Okay, so to know this application of the properties tables using the figures number in the properties booklet. So example, we look the properties of saturated liquid and saturated vapor for water. Okay, as listed A4. So here the temperature uh, is listed here. Okay, specific temperature in unit Celsius. P saturated kilopascal in here. And example, the specific volume, because this is V specific volume. So VF is referred to the point that have in the saturated liquid line. Okay, yang ada kat sini. VG is the state or point that have in saturated vapor line here. So these all the values, okay, that can be used if, okay, example, if I said the temperature here is 90 Celsius, so you know dot dot here is 90 Celsius, so you go to see find 90 Celsius, and then what is the saturated specific volume? What is specific volume for that temperature of water? So the specific volume is 0.001036 meter cube per kg, and it's also specific volume at G is 2.3593 meter cube per kg. That is the answers, okay, for saturated that have in the saturated liquid, and also sorry, that is the answer for specific volume that have in the saturated liquid line, and also the specific volume that has in the saturated vapor. Okay. Okay, let's look on the example to understand more on the situation that I have told you. So, okay, kita tengok the sample problem 2.1. A rigid tank contain 50 kilogram of saturated liquid water at 90 Celsius. Okay. Determine the pressure in the tank and the volume of the tank. Okay. It want you to find the pressure in the tank and also volume of the tank. If the tank contain 50 kilogram of saturated liquid water and it is being heated to 90 Celsius. So in here, you know that the statement mentions saturated liquid water. Okay, saturated liquid water. So what happened? You have to go to A4 as shown in slide 13, or you go to A4. Okay, I bring you up to A4. A4, A4, A6, A5, A4. Okay, A4. Okay, we look on A4. Uh, Pressure, uh, the mass is 50 kilogram, and the fuel is saturated liquid water, and the temperature is 90 Celsius. So we find, okay, at A4, try to find the temperature 90. Okay. Okay, now you find this is the temperature 90. Okay. So when the temperature is 90 Celsius, the pressure saturated is 70.18. Okay, the pressure is 70.18. When 90 Celsius, the pressure is 70.183 kilopascal. Okay. And at that situation, at 90 Celsius, also the V saturated liquid, that's mean Vf at 90 Celsius is 0.001 uh, 036 meter cube per kg. So where to find 0.001036? Okay, we go to the properties table, 90 Celsius. This is for 0.001036. This is for Vf. Okay, Vf. Okay, Vf. But okay, Vf. We have to find Vf first. But you know, to find the volume, okay, to find the volume, the formula of volume is V is equals to V small v specific volume times M. Okay, mass. So mass has been given 50 kilogram. Specific volume has been found. Okay, that means 0.0 ni. Just put into the equations. And now from there you will get the answer of volume 0.0518. Okay, 0.0518. Okay, so this is the answers for volume and also the pressure. Okay, the pressure at this situation. Okay, this is an example how you want to find the pressure in the tank and also the volume of the tank using properties table. Okay. Okay, kita tengok problem number 2. Okay, determine the saturated pressure, specific volume, internal energy, enthalpy for saturated water vapor at 45 and 50 Celsius. Okay, everybody, guys, okay, please answer this question. Determine the saturated pressure. Okay, berapa saturated pressure? From this simple problem. It want to find saturated pressure at 45 Celsius and 50 Celsius. Berapa pressure? How much pressure when the saturated water vapor at 45 Celsius and 50 Celsius? That is the question. Anyone? Sorry? Tak apa dengar.
Sampai tadi.
Ya, tak saya buka balik Tak nampak kan? Nampak atau tak? Okay, pressure. Dia nak pressure. Berapa? Macam mana nak cari? How do you want to find? Give the step to find. Macam mana nak cari?
Tengok temperature.
Tengok temperature. Dia nak cari temperature. So, how do you want to find the temperature? Tengok temperature. Tengok temperature dekat properties table. Is it right?
Yes.
Okay. Kita tengok the temperature because this all yang under this column ke rule? Rule column kan? Okay, under this column, so it have the answer of the pressure. So it's this question say for the saturated water vapor 45 Celsius. So kamu tengok at the temperature of 45 Celsius kat sini 45 Celsius. So the saturated pressure is 9.59 kilopascal. That is the answer. Okay. For 15 Celsius, the temperature is 12.35. Okay, this is only the exercise how you could use the properties table. Okay, bukan this is not the test or exam question. This is only the exercise how you use the properties table. Okay, how about properties volume? If 45 Celsius and 50 Celsius, how about specific volume? Berapa specific volume dia? Anyone? 45 Celsius?
15.251.
45, 15.251. Okay, correct, but correct in term of mathematics. Okay, what I mean that if you want to give the answers of engineering, don't lose your unit. Maksudnya habiskan unit tu kena sebut. Okay, that means you just sebut tadi mathematics. That's why I said that you are right in the mathematics, but in engineering you are wrong. Okay, actually you have to say 15.251 meter cube per kg. That is answer for engineering. Okay, that is good. Okay, that's number one. Another that is for saturated vapor state. Okay, how about saturated liquid for specific volume? Specific volume for saturated liquid berapa? For 45 Celsius. what is the answer for specific volume? Is the specific volume is in the saturated liquid? Berapa? So so if it is 45 Celsius, that means I said the saturated liquid. Okay, so when the saturated liquid, that means the specific volume must be in VF. Okay, VF. So VF here, F refer to fluid or F refer to saturated liquid. So for 45 Celsius, the answer is 0.001010. That is the specific value. Okay, sama juga yang lain. You can make your exercise yourself after this. Okay, that is for problem number 2.2. This one also same as the problem 2.2. Okay, kamu boleh buat exercise ni. Okay, ini jawapan dia sebab okay, exercise ni why it show the answers here because if you look here, it want you to find pressure, specific volume if the saturated water vapor at 45 Celsius. So when you look in this temperature table A4, you don't see, you did not see 47 Celsius. You just see 45 and 50 Celsius. So the 47 Celsius is in between 45 and 50 Celsius. Is in between. So kalau dia berada di antara ni, so you have to make the interpolation. Okay, you make the interpolations. So from the interpolation at here, 45 kat sini. So this value is important and this value is important. How to make the interpolations? Okay, this shows how to get the interpolation. 47, you want to find P set, V kecil, V small u and small h. So interpolation for the P saturated, so you take out P saturated minus upper, okay, 9.5 and then divided by below P set minus upper P set, okay, and this interpolate is same as the concept that have you made early. Yeah, it means 47 minus 45 divided by 50 minus 45. So the answer is 10.698 kilopascal. This is P saturated for 47. So when you check here, 9.6 is in between 10 and 9, 10.9, 10.698 kilopascal is between 9 and 12. So the answer is logical. Okay, so boleh diterima lah. Okay, benda ni do the same principles to others yang lain. That is how you make the interpolations. Okay, dapat? You get? Hello guys. You get the method, get the knowledge. Dapat tak?
Yes, sir.
Okay, because okay, right. Okay, I continue. Can I continue a little bit? Okay, this is on saturated liquid vapor mixture quality. Okay, what this slide want to tell you is that if the case or cases of state is in the mixture region, okay, that means if the state be in the mixture region, example here, okay, example here, inside the mixture region. So what happened? You need to do the calculation to find X. Okay, to find X. X actually is a vapor mixture quality. So let's go for the theoretical. Okay, the statement. During the vaporization process, a substance exits as part as a liquid and also the vapor. Okay, ada dua liquid and also vapor. So this is a mixture of saturated liquid and saturated vapor. Okay, to analyze these mixture properties, we need to know the portion of the liquid and vapor phases in the mixture. So example here, in one system, it have two phases. Okay, one is vapor and another one is liquid, and this another one mixed together and it will become saturated liquid vapor mixture. Okay, to analyze this mixture or to find these portions of a liquid vapor phases, what we have to do is define a new properties. Okay, you have to define a new properties called the quality S. It is a ratio of mass of vapor to the total mass of mixture and also between 0 and it have between 0 to 1. Okay, that's in term of formula, mathematic formula, I put this properties, new properties quality as X is equals to mass of vapor over mass of total. Okay, what is mean mass of vapor? So, okay, let's see. This is an example of the temperature versus specific volume diagram. So, if you look here, uh, M vapor is around berapa percent? Okay, example here is around okay, we take the example as I mentioned. Okay, is the mass of the vapor is 0.2 gram. Okay, here mass of the vapor is 0.2 gram, and the mass of liquid is 0.8 gram. That means total a balance of this mass. Then the quality is 20%. Okay, because we take 0.2 over 100%. So what happened? X is 20%. Okay, that is the quality that can be found, and you know the quality actually mean the mass of vapor. So the X value actually is a mass of vapor in the mixture region. Okay, that you have to understand and remember the concept of quality. Okay, then we take specific volume as an example. Okay, I don't want to take a H, enthalpy, U, etc. We just take a specific volume. The specific volume of the saturated mixture becomes, okay, we give B minus A. Okay, if this is the concept of A, state A here, B here, C and here. So X value vapor is in here between A and B. So A, the state at A, we know this is VF. V is a specific volume that we want to find. Vg, we know this is a specific volume at saturated vapor line. Okay, Vg. So B minus A over C minus A, we put the term simplified B and A states by V and VF, Vg and Vf. So now simplifies these equations, then it will become V is equals to Vf plus X Vg minus Vf. Okay, so Uh, this is how you want to find specific volume. If the specific volume or the state that have in specific volume is in this curve or in between saturated liquid line and saturated vapor line. Okay, that is for specific volume. If we put here as a enthalpy, so the value that you need to find based on the formula of enthalpy. So enthalpy is equal to HF plus X HFG. Also, if it's based on the scale of not specific volume, not enthalpy, specific enthalpy, but based on specific internal energy, so U is equal UF plus X UFG and so on for etc. Example for entropy. Okay. That is how we want to find the properties of quality. How percents of vapor uh, have in the mixture region. Okay. So this is the same moisture content. Okay, moisture content is same as what I said. I said earlier before this. The moisture content of the substance is the opposite of its quality. Okay, the concept is quite. The concept is quite uh, familiar, but the term, the understanding is different. So the quality and the moisture content is opposite. Okay, so uh, if you know the quality is the vapor percentage of the mixture, then the moisture content is the balance of this mixture. So so is in this mixture the moisture you found is 20%, another 20% is moisture content. Okay, and the ratio moisture is defined as the ratio of mass of liquid to the total mass of both liquid and vapor. Okay, this is examples how we find the vapor mixture. So a rigid tank contains 10 kilograms of water at 90 Celsius. If 8 kilograms of water is in the liquid form and the rest of it in the vapor form, determine the pressure in the tank and also the volume of the tank. So you list down what been given in the question. Okay, M, T, and rigid tank. So we draw the system where the system have mg and mf. Mf is 8 kilogram, mg is m total minus mf, so it get 2 kilogram. So to find x, that means the vapor content is mg over m total. So 2 over 10 is 0.2. So 0.2. This is x. Okay, 0.2. So x is between 0 and 1. So x is between 0 and 1. So if you want to find the pressure in the tank, what happened here? What happened or what would you be? You must do is you open the properties table at properties water, find 90 Celsius. Okay, you go for the properties table. Here we go for the properties table. Find 90 Celsius. Okay, 90 Celsius and the pressure is 70.813 Pascal or kilopascal. So that is the answer. Okay, that is the answer. Oops. 70.183 kilopascal. And V volume, the volume of the tank, volume is equals to mv. This is formula for volume because you only know specific volume in the properties table, so you have to use formula specific volume times by mass. Okay, it will give volume. So in the properties table, because this is the mixture because you have 20% or 0.2 uh, vapor in that mixture, so you have to find the exactly volume or specific volume. So using the formula that V is equal to Vf plus SVFG, so put all the things, all the value, refer to the properties table. Okay, we go to the properties table. 90, here is Vf, here is Vg. Okay, Vg, put take these two values, Vf and Vg, put in this equation, Vf and Vg times x. Okay, times x is 0.2, then you will get your answer volume of the tank, 4.72 meter cube. Okay, that is the answer for the tank. Okay, okay, this is another sample. Maybe you can see it in your that's in your room. Any question, guys?
No, sir.
No, sir.
Okay, I will continue. All right. Okay, now we go for the next slide. This is for superheated vapor. Okay, we before this we just concentrate on saturated liquid and also saturated vapor. So in terms of saturated liquid line and saturated vapor line, below of that curve, okay, below of that curve that's been here, this is called what I call it as a mixture region. Okay, mixture region. So now we talk about superheated vapor. Superheated vapor, when the point or the state is you find it is at this region. Okay, dia berada at region yang belah kanan ni. So when it have in this point or state have in this region, it's mean that the condition of the fluid in the phase of gas, dalam keadaan gas, sebab dia dalam fasa gas, sebab dia adalah vapor. Okay, warp, superheated vapor. So in the region to the right of the saturated vapor line and temperature above the critical point where the substance exits as a superheated vapor. That's what I mean, and I want you to know. In this region, temperature and pressure are independent properties. So compared to the saturated vapor, superheated vapor is characterized by, this is all the theoretical, lower pressure, that means higher temperature, higher specific volume, higher internal energy, and also higher enthalpy. So this is for superheated. Okay, how we want to find this? Okay, superheated vapor, when you want to find, you have to go in the properties booklet at table which one? Table 4, no. Table 5, no. Okay, superheated water. So if you want to analysis and do the calculations based on the properties table for superheated vapor, you have to use the properties table in table A6. Yang ni lah, yang banyak-banyak A6 until all A6. Okay. Okay, okay, this is some example. Okay, solutions. This is okay. This one you can do it yourself. We go for the next example. Okay, here because this have the solution. Okay, determine the temperature of water. Okay, determine the temperature of water at the state of P equal to 0.5 megapascal and 2890 kilojoule per kg. So it gives two properties. Okay, remember, if you want to look on the superheated table or superheated water, the requirement is you must have two properties at least. Okay, two properties at least to see or to find answer in superheated water table. Okay, macam ni. So this question it give the this indirect informations two properties. Pressure is 0.5 and I think this is it is clear that H this is H. H is 2890 kilojoule. Okay, then okay, from there, from table A5, you know the H is 2890. Okay, H is 2890 and P is 0.5. So find P is 0.5. Okay, you find pressure 0.5. This pressure for 0.5 and then H. H is H is 2890. Okay, H is 2890. Okay, 2890 now is it is in between. Okay, that means you have to do a interpolation. 0.5 megapascal. Uh, it is in between. So uh, okay. So at 2855 and 2961, H is in between these two values, and the temperature you can find when you calculate these values using interpolation method. So when you do the interpolations, you get the temperature is 216.25 Celsius. That is the answer for this problem. So this simple exercise also want to show you how to find the numbers in the superheated table. Okay, this is another equation. Superheated. Uh, okay, and another one is compressed liquid. So the compressed liquid, as you know, all known, the compressed liquid phase is in the left side of the graph of the saturated liquid line. So this is a compressed liquid. So the data, the properties that show on the compressed liquid is at table A7. So it is not commonly available because it is relative independence of compressed liquid properties for pressure. So what is mean here actually it is not important to deal in the thermodynamics, but you have to know how to calculate if this phase of a compressed liquid being asked as a case to you. Okay, so in general, a compressed liquid is characterized by high pressure, lower temperatures, lower specific volumes, lower internal energies, and also lower enthalpies. Okay, this is all the theoreticals of the compressed liquids. So notes that compressed liquid properties are not much different from the saturated liquid values. Okay, please take notes about that. So this is example, okay, for you to find, okay, to find the compressed liquid analysis. So let's look on it. Determine the internal energy of the compressed liquid water at 80 Celsius and 5 megapascal. Okay, so you using data for the compressed liquid tables and also saturated liquid data. What is the error involved in the second case? So from here, solution when we use tables, okay, tables A5, uh, 5 megapascal, it will get 263.94 Celsius. And it is clear that the temperature at T Celsius is less than T saturated at 5 megapascal. So we can make the conclusions that the water is compressed liquid. Okay, because sebelum ni we don't know whether the fluid is compressed liquid or uh, in mixture region. So you have to find firstly, is it the fluid is in the situation in the conditions of mixture or in the condition of compressed liquid. So this is how you find whether the water is compressed liquid ataupun mixture region. Okay. Okay, from compressed liquid table, okay, ni using A7 for compressed liquid table. When you have conclude that is a compressed liquid, so you jump to the A7 compressed liquid. So at that 5 megapascal temperature 80 Celsius, you can find U internal specific internal energy. Okay, and also B saturated liquid data. So for table A4 for saturated table A, we know that the temperature saturated is 80 Celsius. So UF also you can get from that properties tables. So to check the error in the specific internal energy, so this is a formula that can be used. Time this is a general formula, so you will get the percentage error is 0.345%. That is quite a low percentage. Okay, this is all the practical problem. You can, as a exercise, you can get, you can try to solve these problems. Okay, and maybe if you have the problem you cannot solve, and then you want to ask, you can ask me on the tutorial. Okay, so this is also the practice question. So we come from the part 3. So I think this that's all for part 2, chapter 2, properties of pure substances. Okay, so any question from you guys? Anything regarding with part 1 dan juga part 2?
No, sir.
Okay, masih lagi tidak ada soalan, semua faham. Alright. So wait, I so okay, stop and record.